before we get to our next function, I just want to explain. I've explained actually the point of inflection. I've explained all those points. For you to find your point of inflection, it's quite easy. You just find your second derivative, which is the derivative of the first derivative, take it, equate it to 0, and then solve for x, and then you take that x value, you substitute it into the original equation. This is the original equation. Wherever there's x in the original equation, I'm just going to substitute this -7/6, and it'll give me 55/54, and that will be your point of inflection. Remember, at the point of inflection, your graph is increasing if it's increasing at that point. However, at that interval, however, the rate of the increase or the decrease is changing. So basically, if it's increasing after the point of inflection, it'll increase at a decreasing rate, getting ready to go down, or it'll keep on decreasing, and but however, at the point of inflection, it'll decrease at a decreasing rate, getting ready to go up. Okay, now in this case, we're going to plot another graph, which is this. Please note that the coefficient of this graph is simply +1. Remember, first step, you first find a in this case is 1, which is greater than 0, meaning that your graph will simply take this shape. Know that our final product must look like that. Now your x-intercept, take the original equation where there's x, substitute 0, and then you will realize that actually where there's y, substitute 0, you'll realize that where there's g of x, I simply substituted 0, and then you solve for x. Okay, this is an equation, it's a cubic equation. Find a factor. My factor is 1, meaning that if I substitute 1 into this equation, I will get 0, hence my factor will be x minus 1. Obviously that factor, binomial factor, must be multiplied with a trinomial. What must I multiply with x for me to get x cubed? The answer is very easy, it's just x squared. What must I multiply with -1 for me to get +2? And the answer is just -2. -1 times -2 gives you +2. The problem is here. Now, because I don't know what my middle term is, I know that it must have x, but I don't know what the coefficient of x is. So all I'm going to do is this powerful method. I'm just going to multiply those two. You can just multiply the coefficients without multiplying x's. Here I multiply the x's. So basically I took x times bx, gave me bx squared, and -1 times x squared gave me -x squared. But because in my original equation, in my original function, I don't have x to the exponent of 2, I'm going to add it. So basically it's supposed to be there. Meaning that it'll just be 0x squared. So that's why I have 0x squared. If you don't have x squared in the original equation, you just equate it to 0x squared. Now I will have done it. Obviously I took out a common factor on the left hand side and I divided both sides by x squared, and this is what I got. Okay, I could have just used the coefficients by just saying 1 times b is b, -1 times 1 is -1. It'll be equal to 0, which is the coefficient of x squared, and it's not there. All you're going to do now is to take this b and substitute it into my trinomial factor. So where there's b, now I have 1. Okay, fully factorize that. This is a simple trinomial to factorize, and you will get that. You'll realize that you'll have x minus 1. X is equals to 1 and x is equals to 1. So just write it once, and you'll have x is equals to -2 when you solve for x, meaning that your graph will only touch the x-axis twice. If your cubic graph touches your x-axis twice, you must just know that probably one of the x-intercept is a turning point. Okay, now these are my x-intercept. For my y-intercept, I just need to emphasize this. The reason why I always write the original equation, I'm trying to show you that after every step you use the original equation. You don't go to the previous step and use whatever you got in the previous step. No, every step you use the original equation. I'm going to go back into my original equation, and where there's x, I'm just going to substitute 0, and I'll have my y value, which is 2. All right, meaning that my coordinate will be 0 and 2. Now I have found the coordinates of the turning point. I've also found, I have found the intercepts. Okay, all I need to do is to find the coordinates of the turning point. Immediately I mention the turning point, please, you need to put this into your brain. Turning point, first derivative equated to 0, solve for x, period. And then whatever x value you get there, you substitute it into the original equation. All right, all I'm going to do is to take the original equation. I have the first derivative. I'm going to take that first derivative, equate it to 0, and simply solve for x. Obviously, for me to solve for x, I have 3x cubed minus 3. Take out a common factor, divide everything by 3, which is your common factor. You will be left with x minus 1. That is a difference of 2 squares. So I'll have 2x coordinates. X will be 1 and x will be equal to minus 1. These are the x coordinate of the turning point. I repeat, these are the x coordinates of the turning point. Now, for me to find the y coordinate, the y coordinates of the turning point. I am simply going to substitute these x coordinate, I repeat, into the original equation. So I took the original equation and I substituted the first x coordinate of my turning point, and again I went back to my original equation and I substituted my second coordinate of my turning point. You'll realize that this is the y coordinate of the turning point is 0. Of the first turning point will be 0. The y coordinate of the second turning point will be 4. Now all I have to do is to determine whether these coordinates at this turning point, is my graph facing up or is it facing down? When we talk about concavity, remember this: second derivative. Concavity, second derivative. All right, all I'm going to do now is to find my second derivative and substitute the x coordinates of the turning point. Go back into the original equation, find the first derivative, and then find the second derivative. I simply used my first derivative to find my second derivative. Remember the x coordinate of the turning point. The first one was 1, the second one was -1. I'm going to start with -1. I get -6. Immediately realize that you get a negative value when you substitute into the second derivative. You just need to remember that the y coordinate of this -1, the y coordinate of that -1 is a relative maximum. If the y coordinate is a relative maximum, it means that at that turning point, your graph is simply concave down. It means at that turning point, your graph is simply concave down. So whenever the second derivative is negative, at that turning point, your graph is concave down. Negative second derivative, concave down. Negative second derivative, concave down. Positive second derivative, concave up, all right? Making the y coordinate of your turning point a relative minimum. Now, point of inflection, take your second derivative equated to 0. Take the 0, substitute it into the original equation, and you will get 2. So basically, your point of inflection will be 0 and 2. And this will be your graph. You'll realize that I simply start by first plotting my intercepts. And then I plot my turning points. Obviously, that will be my turning point, and this will be my turning point, and this is all I do. So this is how I will plot it. And there from there on, all I'm going to do is just to extend this line and make sure that it passes through my x-intercept, and extend that line and make sure that it passes through my y-intercept as well as my x-intercept. But that x-intercept, it doesn't go down, it goes up again, which is your turning point, and I'll have my full graph. This will be your exercise 1. Please plot that, this, that, and that will be the last one.